Hey guys, this is Mrs. Cutting, and I am going to do lesson 8, parts 8.1 and 8.2 with you today. So, when I ask you to pause the video and do something, I'm going to expect that you actually pause it and try it on your own or with your shoulder partner for a minute before coming back to the video. Okay, so 8.1, composing parallelograms. Here is triangle M. Han made a copy of triangle M and composed 3 different parallelograms using the original M and the copy as shown here. So 2 copies of M made 3 parallelograms. First it says for each parallelogram Han composed, identify a base and a corresponding height and write the measurements on the drawing. So you're going to grab a highlighter. You're going to highlight a base and a height. Remember, they need to come together to make a 90-degree angle. And then write how long the base is and how high the height is for each of those. So please pause me, do that, and then come back to me once you're done. All right, so for that first one, I'm going to use this as my base. And my height needs to be at a 90-degree angle. I'm just going to go about right here. So my base is 1, 2, 3, 4, 5, 6 units, and my height is 1, 2, 3, 4 units. For the second one, I'm going to kind of picture it being on its side, and I'm going to call this the base, because the base does have to be one of the 4 sides of the parallelogram, and then I'm going to call this the height. So really I'm picturing my room more like this. And here the base is 1, 2, 3, 4, and the height is 1, 2, 3, 4, 5, 6. And this last one, I'm going to have my base be down here and my height be right here. Oh, I forgot to mark that that's a 90-degree angle. Oops. So here my base is 1, 2, 3, 4, 5, 6, and my height is 1, 2, 3, 4. Makes sense that it's the same 2 numbers for each of those because we're using the same triangles in each of them. Okay, then it says find the area of each parallelogram Han composed and show your reasoning. So please pause me. You're going to either down here or up in here somewhere, you're going to find the area of each parallelogram. Okay, that first one, sorry, I just didn't think that showed up very well in pencil. That first one, my base is 6 and my height is 4, so since I know base times height equals area, I'm going to do 6 times 4, which is 24 square units. This one, my base is 4 and my height is 6. So for that second one, I'm going to do 4 times 6 equals 24 square units. And for the third one, my base was 6 and my height was 4 again, so 6 times 4 equals 24 square units. Now, the book doesn't ask you this, but I am going to. Let's say that instead of finding the area of the parallelogram, what if I just wanted the area of one of the triangles? I want you to think for a second. What would we need to do if we know that the area of the whole parallelogram is 24 square units? What would we need to do to find the area of just one of the triangles? Well, since this is the area of 2 of the triangles put together, to find the area of just one of the triangles, I could do the area of the whole parallelogram and divide it by 2. So, for just the triangles, since 2 triangles together are 24, I can do 24 divided by 2, which is 12. So the area of just one of those triangles would be 12 square units. copy that down so you have it in your workbook. And then turn the page with me. Okay, so here they have us dive right in. Find the areas of at least 2 of these triangles and show your reasoning. Okay, well, what we know so far is that 2 identical copies of a triangle can come together to make a parallelogram or a rectangle. So if it takes 2 copies to make a parallelogram or a rectangle, if we want to find the area of just one of the triangles, we can find the area of the whole parallelogram or rectangle and then divide it by 2. So we're not going to do just 2 of these. We're going to find the area of all 4 of these. But I'm going to model it with a different page. So you stay on this page, and I'm going to flip forward for a moment. Okay, so I am going to model it here. And I'm going to ignore those directions because I just want to use these triangles. So if I wanted to find the area of triangle C, I want to end up drawing a second copy of triangle C. And because it's not lined up with the grid super well, it's kind of hard to just look at it and know where to draw it. So I'm going to attempt to use tracing paper to help me out. So here's my triangle C. I'm going to put my tracing paper over it, and this is going to be a little bit weird. I'm warning you, a little bit weird. So I could trace the whole thing, but I'm actually just going to put a dot where my 3 vertices are, where those 3, I want to call them corners, but they're not really corners, where those 3 corners are. Okay, and then to make this into a parallelogram, I would need to flip this around and put it here. So a couple of options for how we can do that. I can lift up my tracing paper and say, okay, that first dot needs to go right there. That second dot needs to go right here. And this third dot needs to go over here. Or, this is the kind of weird part, and if you come up with a better way of doing this, you guys can let me know tomorrow. If I flip my tracing paper upside down and redraw those dots on the back, and then put it back where it needs to go, that is not how it needs to go. That is not either. Okay, and put it back where it needs to go. And then just press on this a little bit with my pencil again. It should kind of give me an idea of where those dots go. It kind of like presses the lead in. I know this isn't the best system. And then I can use an index card to help me out. So another option, if you saw that and you were like, whoa, why would she do it that way? That's totally weird. I could trace it. I could trace the whole thing. And then I could use scissors to cut it out. And then put it back on here and then kind of trace around it. And if you come up with a better system of how to trace this other part, I would love to hear it. Okay. Back to whatever page we were on, page 54. So you have 4 triangles, and you're going to turn them into rectangles or parallelograms by making an identical copy somehow with tracing paper, by cutting it out, however you feel like trying it. But it should end up making a parallelogram. Then, once you have your parallelogram, you can find the area and then cut that area in half. So I'm going to have you pause me and at least give it a try. I don't believe you gave it a try yet. Pause me for longer and at least give it a try. All right, maybe you did it for real this time. Okay. So for A, here are my 3 dots. I'm going to retrace them on the back. Then I just got to figure out which way this goes. There we go. And now use my pencil to kind of press down a little bit. And it's not real sharp, but there are my 3 dots. And this one, because it was a right angle, it's a rectangle. So now that I have my rectangle, I'm just going to do base times height. So my base was 1, 2, 3, 4, 5, 6, 7, 8. And my height was 1, 2. So 8 times 2 equals 16. So that's the area of this entire rectangle. But I don't want the entire rectangle. I just want half of it. So now I'm going to do 16 divided by 2, which gets me back to 8. So my area for A is 8 square units. All right, so my videos on this program are only allowed to be 15 minutes long. So I am going to pause my video while I trace the other half of my parallelograms, and then I will be back, if I can figure out how to pause myself. Okay, I am back. If figuring out where exactly the other triangle goes was confusing to you, we're not going to stress out about that part. So now I have turned them all into parallelograms. If you were not successful at making them into parallelograms, it's not that big of a deal, okay? You can just kind of look at where my dot is and try to draw it in. Now we're going to find the area of our parallelograms. So now I have a base like this and a height like this. I have a base like this and a height like this. And this one, I have a base over here, so this one's kind of sitting on its side, and a height like this. So take a second with a highlighter and highlight those. We're going to go back and mark our 90-degree angle. So for B, my base was 1, 2, 3, 4, 5, 6, 7. And my height was 1, 2, 3. So the area of the whole parallelogram is 21 square units, but I just want this half. So 21 divided by 2. Well, 20 divided by 2 would give me 10. And then that extra 1 divided by 2 would give me a 0.5. So 10.5 square units. For C, my base was 1, 2, 3, 4, 5, and my height was 1, 2, 3, 4. So 5 times 4 equals 20, but I only want half, so 20 divided by 2 is 10 square units. And for D, my base was 1, 2, 3, 4, and my height was 1, 2, 3, 4, 5, 6. So 4 times 6 equals 24, but I only want half, so 24 divided by 2 is 12 square units. Okay, we will talk more about all this when I get back, but now you have one more little thing to do. You have a practice thing on this program called Desmos, and I will be back tomorrow, and I have 20 seconds to spare on this video. Oh, which is good, because I need to give you a secret code word. Your secret code word is mango. M-A-N-G-O. M-A-N-G-O. Okay, bye.